Everyone, I, Sir Sylvester de Souza, welcome you all to the geography lecture of the ninth standard. Students, in the previous lecture, we were discussing on the second lesson, that is endogenetic movements of your ninth standard. In that, we had divided various types of movements, that is slow earth movements and sudden earth movements. Now we had finished up with the slow earth movements. Today in this lecture we shall continue with the sudden earth movements. My dear friends, we had seen up to the continent building in the previous lecture. Today we shall start with the sudden movements. Now, in the beginning of the chapter we had discussed and studied the news item on the earthquake. So the first thing that you had studied in the second lesson was a news article related to the earthquake. I hope you all remember that. Okay, we had even answered a few questions which were there below it. Earth means the ground and quake means trembling. So basically earthquake comes from two words, that is earth, which means the ground, and quake means trembling. Trembling means a kind of a shaking, a kind of a movement what occurs. Earthquake is the movement of the earth's crust. So basically the movement what we feel during the earthquake is in the crust of the earth. You had studied this in your last year 8th standard second chapter, the interior of the earth. So in that you had seen the layers of the earth, what is there in the interior. So in that it is the earth's crust which is facing the movement. You have been acquainted with the magnitude and the effect of the earthquake through the activity at the beginning of the chapter itself. So my dear students, you had seen words like magnitude, words like effects of the earthquake, then words like the Richter scale, the places which were affected. So you have seen all these things in the activity in the beginning of the chapter. Now we will look at the sudden movements called as earthquakes and volcanoes in the interior in detail. So this particular lecture, I am just focusing on one movement, that is the earthquake. Okay, let us begin. Earthquake. Because of the movements occurring in the interior of the earth, tremendous tension is created in the earth's crust. When the tension goes beyond the limit, the energy is released in the form of waves. This results in trembling of the earth's surface, that is earthquake. The magnitude of the earthquake is measured by Richter scale, which you can see it in figure 2.11. This is the figure that you can see. Now first of all, let us start discussing. Okay, so as I told you, what is earthquake? Earthquake comes from two words, that is ground meaning the earth, and then quake meaning trembling. Now the movements what occur, my dear students, are occurring in the interior of the earth. Okay, they are occurring somewhere down within the earth's surface, but due to that a tension is created in the earth's crust. So earth's crust is the uppermost layer. Okay, there we can feel the tension. Now it is that earthquake are felt in various magnitudes, that is we can divide them according to Richter scale in various magnitudes, that is the force or the energy of the earthquake. Okay, it is mild, it is moderate, and it is large. Okay, it's even very severe also at times. Okay, so this results in trembling. So there is a trembling, there is a movement what occurs on the surface of the earth, and once these kind of trembling, once these kind of movements occur, we can say that an earthquake has taken place. Now the way of measuring the earthquake is used, it is called as a Richter scale. Okay, so this is a seismogram what is used, and the down what we can see over here, this is the graph what is drawn due to this seismograph. Okay, what is used. Next, there are various reasons why the earthquake occurs. So the first thing is the moving of the plates. So first thing that we see is there is a movement within the earth's surface. You might have heard about tectonic plates. So there are tectonic plates within the earth's surface. So these keep on moving. Then the next thing, that is colliding. Sometimes there is a collision. Collision is a dashing between the two plates. Okay. Then the third one is plates sliding one below the other. So at times what happens, there is a plate which slides below the other plate. Slides meaning slips below the other plates. Then at certain time there are formation of fractures in the rock layers due to tension in the interior of the earth. So sometimes what we can see a fracture is developed in the rock, and due to this fracture sometimes there is movement on the earth's crust, and sometimes even due to volcanic eruptions earthquakes can occur. Okay, so these are the various things why earthquake occurs, okay, or the reasons behind the cause of an earthquake. So we had seen what is this waves, or there are few questions that are asked like what shaking of the earth surface, what waves, what is this energy. You must be having all these doubts. Now let us go into them one by one. See, I told you we can see the earth's mantle here in the interior. Above that we can see this green and blue, that is the crust. Now this crust is not a whole layer, but they are divided into something called as tectonic plates. Okay, these are various plates that are divided. Now here see, we can see it is the mantle, the inner layer, and then we have got outer. Okay, at the out we have got the above layer, what we can call it as the crust. Okay, now there are these movements what occur in the interior of the earth, and they differ from 1 to 10 centimeter each year, and it is not necessary that we feel all the tremors of the earthquakes. Certain times they are very, very mild and we don't even feel them. Okay, they are not even felt, but there are movements which are occurring in the interior of the earth. Okay, so they are coming in these kind of waves. You can see these circles. So these waves are what comes and hits us on the earth crust. Okay, now here I have got a diagram of the interior of the earth. So we can see the lithosphere, that's the place where we stay, that's the crust where we stay, and below that we have got the mantle, then we have got the outer core, and then we have got the inner core. Okay, now let us see about the focus and the epicenter. These things you had heard in the introduction of the chapter itself when you were reading the news article. Because of the movements occurring below the earth's surface, tension is created and it keeps on accumulating. So what happens, there are movements which are occurring in the earth's interior, okay, and then there is tension which is created. There is a lot of tension within the earth's surface, and this is not once, this happens over and over a period of time, and due to this it keeps on accumulating. Accumulating is nothing but gathering. High tension is released at a place where this tension mounts up. So what happens, once the pressure is too much, okay, say for example you are going on blowing air into a balloon, till certain time the balloon will able to hold the pressure, but after some time what will happen, automatically the balloon will burst. Okay, so that is what happens in the interior of the earth. After accumulating, once the pressure cannot be borne, then automatically there is a release of the pressure. This is the center of the earthquake. It is called as the focus or the hypocenter. So here we can see, here was the place, my dear students, the focus where the tension was created. It was going on accumulating, and once it could not hold it, then it is released. Then energy waves are scattered in all directions from this center. So you can see these energy waves. These are all waves that are moving in all directions. They are moving in north, they are moving in south, they are moving in the west, they are moving in the east. They are moving practically in all the directions. Okay. Now the place on the earth's surface where these waves reach first is called as the epicenter of the earthquake. So my dear students, you can see from the focus over here, right at the place over here, right on top, we have got the epicenter. This is the place where the waves reach the first. Now it is 100% sure that it is the shortest way. See here you can see these are longer than this. Here, if for example there are waves moving in all the direction, but this is the shortest, which comes exactly parallel from the point of the focus to the earth's crust. Okay, and that is what is called as the epicenter. It is the nearest place on the earth's surface from the focus, and it experiences the first tremor. So we can see from the focus, it is at this point that for the first time the tremor will be felt. Tremor is nothing but movement. So it is perpendicular to the focus. It is straight from here 90 degree exactly from the focus is the point over here that is known as the epicenter. When the tension is released at the focus, the energy released travels in all directions. So just as I told you, it travels in all the directions. Okay, this energy comes to the earth's surface in the form of waves. So what we can feel it is only in the form of waves. Okay, we cannot see the movement, but we can only feel them, and it is felt due to the waves what is released from the focus. The seismic waves can be divided into primary, secondary and surface. So as you can see over here we have got the primary, then we have got the secondary, and here you can see here is the surface waves. Okay, so they are divided into three kinds of waves. Okay, now as I told you, it is called as the hypocenter. See here it is written over here on top. It is also called as the hypocenter, or it is also known as the focus. Okay, here is the hypocenter or the focus, and exactly perpendicular to that we have got the epicenter. Okay, now here I have got a few examples. One of the most massive earthquakes the earth or we have ever felt it, or the mankind has ever noticed, is at Chile, a place called as Chile, a country called as Chile, and it was in the year 1960. That was about 9.5 magnitude, and this led to something called as a tsunami. And the second most severe one was in Japan. It was 9 magnitudes, and it was in the year 2011. This most of you all might have heard it or even seen it in the various news channels. Okay, my dear students, next this is what is called as seismic waves what are coming, okay, due to the movement of the seismogram. Okay, and the image what is drawn over here, it is called as the seismograph. What we get is called as the seismograph. Now I told you the magnitude of the earthquake can be divided into various scales. Okay, so here are the scales from 0 to 2, that is barely sensed. There are moments, but we barely sense it. Most of the time we don't even feel it. Okay, then there are some minor vibrations sometimes you feel, that is at a magnitude of 2 to 4, and then 4 to 4.9 we have got small or light earthquakes where it is very light. Okay, there is minor or small earthquakes without much of damage. Then there is moderate where there is somewhat damage, and then we have got 6 to 6.9. They are very, very strong, and much stronger than that are above 7. So imagine the earthquake which occurred in Chile, okay, and which occurred over here in Japan. Okay, Japan and Chile were about 9.5, where we have got the ratings of about 10. Okay, it is measured up to 10 magnitude, okay, on the Richter scale. So here I have got the inner core. It's the innermost part of the earth. It's like a spherical ball in nature. Spherical is it's round. It has got a radius about 1250 kilometers. Okay, and this is the inner core. Okay, next we have got the outer core. This is at about the thickness of 2200 kilometers, and it has a very, very high temperature of 4500 to 5500 degrees Celsius. So this is the outer core above the inner core. Then next one we have got the mantle, my dear students. So mantle is in semi-solid state. Okay, it's not completely solid, not completely liquid, it's in semi-solid, and the thickness of it is about 2900 kilometers, and it covers about 84% of the earth's total volume. So it is really very big, or the biggest layer is called as the mantle, and the smallest layer covering 1% of the total earth's mass. Okay, it's as thin as an apple skin. So when you eat an apple, as you see, the skin of the apple is very, very thin. That's all the crust looks like when you look at the entire earth. Okay, it has got a thickness of about 0 to 70 kilometers. Okay, then the primary waves. Now these are waves, the first one to reach the surface after the energy is emitted in the earth's interior. So the first waves which ever felt are the primary waves. Therefore they are called as the primary, the first waves. They travel at a very, very fast speed. So they are traveling at quite a fast speed. Okay, then they are moving in all the direction, that is they move in to and fro directions. Okay, to and fro is nothing but front and back. Say for example, you say I am going from here to a particular place. So to is going, and fro I am coming back. So to and fro movements. So therefore they are also called as forward and backward waves. They are also called as forward and backward waves. So these can travel through all the three states, that is liquid state, solid state and the gaseous state. So they move in all the three states. Okay, but sometimes, as I told you, while traveling in the liquid medium, their direction may get changed. Okay, their directions sometimes get changed, and it's because of the primary waves that we feel in the earth's surface a backward and a forward movement. Okay, that is back and forth movement. Okay, so this is the view of the earth when you see it from the above, my dear students. So if you see at the earth from this view, we can see that the buildings are here on top and they are on the layer called as the crust, and below the crust we have got the mantle. So this is the upper view, and this is the view that we see the interior of the earth, my dear students. Okay, so here we have got the primary waves which are moving. I told you they are to and fro waves, and they can pass through all the three medium. Okay, and they move in parallel direction. That is to, that is moving this side, and fro moving this side. They are moving in this kind of a direction. Okay, see here we have got the first wave that they have felt, that is the primary waves. Next, my dear students, is the secondary waves. The waves which reach the earth's surface after the primary waves is called as secondary waves. So after the primary waves are coming, they are known as the secondary waves. Now they also move in all the direction. Their velocity is lesser, so the speed of them is lesser than that of the P waves, but they are more destructive than the P waves. Okay, so you can see that here their velocity is less, but they are much more destructive, and they move in upward and downward direction. So in somewhat this kind of a direction, that is what is called as upward and downward direction. They can travel only through solid medium, so they can travel only through solid, whereas primary waves were traveling through all the three, that is liquid, solid as well as gaseous. Okay, see here we can see them, secondary waves. So these are the movements, that is up and down, what you can see movements over here. Okay, so this is the movement, you can see this up and down, so they are moving in this kind of a movement. Okay, my dear students, here we have got the secondary waves, and at the last we have got the surface waves. Now they are the most destructive, okay, because they are moving parallel to the earth's crust. Okay, that is they move on the earth's crust. Okay, you can see this in the diagram of the earth's crust, in the earthquake diagram also, what is given to you all. Okay, the next one, seismogram, is nothing but an instrument which is used to measure the earthquake, and we can understand the magnitude of the earthquake. Okay, now today, due to modern technologies, we have got seismograms which are advanced, and today we can even find it out on the mobile devices using certain apps, due to these kind of radioactive gases what are there, which are released on the earth's surface. And the last one, my dear students, is the effect of the earthquake. So if you see the effects of the earthquake, you will see that there are cracks which are developed. You can see plenty of times whenever there are earthquakes, there are cracks on the walls, there are cracks on the grounds also. Then there is also landslide also which occurs. Landslide occurs mainly in the mountainous regions. Sometimes there is a change in the groundwater course. So if you see, certain times we can find out that the groundwater changes its course, changes its path. Okay, then areas gets uplifted. Certain time, due to sliding of plates, certain areas may go down and certain areas may come up, that is get uplifted. In certain places, tsunamis are also generated. Places in the mountainous region which are covered by snow, we can see that there are avalanches. Okay, next we can also see building collapses. There is loss of life and property. Transportation gets disrupted. Sometimes bridges are damaged, bridges breaks. Okay, there are roads which are damaged, and even the communication systems get damaged. See here we have got a small GIF of the earthquake. You can see how the roads are developing, areas getting subsided. Okay, that is areas getting disappeared. Next we can see how tsunamis are generated. Okay, destroying the entire buildings, destroying everything what is there. Then we have also certain things. Okay, these are certain things that you have to, precautions that you will take whenever an earthquake occurs. That is, you have to make a plan first of all. That is certain times now we can before the earthquake coming, the government sometimes can tell us, okay, that there may be an earthquake in a few days. So what happens at that time, when we know, okay, that there can be an earthquake, we have to make a plan what important things we require to take with us in case there is an earthquake, how to secure our home, how to keep the kit ready, that is the first aid kit, how to protect ourselves in case there is a sudden earthquake, and also to check for various hazards, like for example standing away from the electric poles, okay, and electric wires. And the most important thing is to stay connected. Okay, so today's lesson we have seen about earthquakes. In the coming lesson, I will tell you, in the coming lecture, I will teach you about volcanoes, only a small part of volcanoes, what is necessary, and then I will do a quick revision so that you can get ready for the unit test.